Hello people of the internet. If you are Copper users, you may have noticed that there is a full S390X outage. If you go to the Copper website, you can see Copper is taking its time as usual. Anyway, you can see there is this banner telling us that there is the full outage linking into the issue I've shown previously. So today we are going to do something about that. Now, two things first. Why there is an outage? So basically, suddenly our API key stopped working into the IBM cloud where we spawned our S390X virtual machines, and basically after some discussion it turned out IBM cloud is dead. I don't know, there were my other two teammates and I don't know the full details, but yeah, so we kind of don't have any options where to run the S390X VMs natively now, which really sucks. So together we are going to switch all of our S390X builds from native builds to be emulated builds on some other architecture, which sucks, but it is better than a full outage. And one of my teammates said that he's going to work on getting us access to S390X instances at least till the end of the year, so that we can have enough time to migrate somewhere else. That's roughly what I know. So we will take a look at switching to the emulation now. Anyway, if you are not Copper user and don't use these architectures and so on, I want to show you a little bit of introduction to what's going on here, so you can follow the video if you want to. So basically in Copper we build, you submit your source code and we build for the Fedora versions and architectures that you choose, right? So we have PPC 64LE, we have S396, we have ARM, we have x86-64s. Yeah, the numbers in English giving me hard time. So we have all of those you can choose, and basically on a technical level we have several pools of builders where we can spawn the virtual machines which will do the builds. So if we go to Copper, there should be a link somewhere. I don't know where actually. Let's see the footer. I know how to get there by this, right? Resalloc, this one. Still loading. Yeah, this one. Somewhere in the Copper web UI there is a link to this. And basically you can see the resources. Hopefully it will work. Yeah, you can see the resources and basically you can scroll down. There is a lot of them, right? And this is all the virtual machines that we have currently up and available, right? So you can see there is a different state. So some of them are starting, some of them are currently running builds and so on. And you can see this one is in this pool, this one is in this pool, this pool. So we have a lot of pools, it seems, right? And each pool provides some machines, right? So we have we have, for example, this pool of x86-64 machines on a VM host, so basically on our hypervisor. And also we have x86-64 in AWS. So basically we have a lot of redundancy here. If our machines, our hypervisors go down, it doesn't really matter because we still spawn x86-64 in AWS, so there is no outage, right? We have this same this is same redundancy for PPC 64LE builders. So we have them on our hypervisors and in I don't know if we have them in AWS. Are there PPC in AWS? Anyway, we have we definitely have OSU, which is Oregon State University lab, which provides us these machines. So yeah, we have a redundancy for all of the for a lot of the architectures. We don't have redundancy for S390X. So that's bad because a situation like this happened. Our access to the cloud got somehow broken and we basically have no builders for that architecture. And if you take a look at the queue, so we can go to pending. And we can go to detailed. Yeah, this will take a little bit. So if we go to the very bottom, there is a queue by architecture. There is 2000 builds for S390X, and they are basically like not being processed at all. So this is stuck. These are waiting forever basically now. So yeah, this is the whole situation. So yeah, we finally can do something about that. Okay, so you know all the details how it works now. You know basically as much as I know because this is I haven't configured this for a long time. Now I have no idea how to switch to the emulated one. So I've probably never done this. So let's take a look into the Copr documentation. Maybe there is a documentation for that. So we have how to manage active chroots. Yeah, that one seems reasonable. So let's start there probably. We have Resalloc. We can take a look there as well. I don't think there will be anything relevant. So Resalloc, yeah, this is just no, this is not relevant. How to manage active chroots? How to manage chroots? So I've personally written a lot of this documentation, and I don't think it is going to be here. So branching process, not our situation. End of life deactivation, non-relatable here. Managing chroot commands. Okay, so this I didn't write this section, and this could be relevant. I can already see some emulated here. So we can comment on chroot with something. Okay, that's fine. This was though a single chroot command. There is a better option for those Copr instances that contain dozens of chroots. chroots template. What the hell is this? I have never seen that. Template on this. Okay. So I suppose we have some chroots conf somewhere. And then we do some stuff. Okay. I don't understand why config emulated is not true or false, but it is this. But we are going to try and see if this file exists on our server, right? That would be probably a good idea. And SSH, let me go to here. So we are on the Copper backend. That's probably not the place where I would look for it. Yeah, Copper frontend is mentioned here. It's Copper frontend command, but I suppose Copper frontend command is going to be ran on Copper frontend, right? So let's go to Copper frontend and let's try to see if this file exists. Oh, it exists. Okay. So is there anything interesting? Config match. Okay, so we are basically adding this command for all of these chroots. Okay. And emulated chroot builds are done on. Okay. So that's good. That's good because we basically can see how these chroots are done and do our new S390X chroots the same way, right? So first things first, we are not going to work on production. That's a bad idea. So let's go to Copper staging instance. And why is everything so slow? Even my brain can speak today. What the hell? So new project. We will create a new project and we will submit a build there for several architectures, and we will expect all of them to finish except for the S390X. And then we will do our stuff to make sure it starts running, right? So let's do Fedora 43 and let's enable, I don't know, all of them, right? So if we need to specify the name of the project, so test architectures, right? Create. Yeah, we are on the staging one. Okay, build. This is slow. Dist-git, and we will submit a new build. Doesn't matter what package. Oh sweet baby Jesus, this is slow. I don't know why. Okay, so while this is running, we can find our config for the S390X on the staging instance. Yeah. So what we expect here to happen, this should build fine, this should build fine, this should definitely build fine, and this one should get stuck in pending, right? Let's refresh and let's see. Okay, starting. Okay, maybe in starting even, maybe not even pending. But all of the other ones should finish. Now let's go to Fedef. So this is our staging front end, and we will see the same file here. Yep, this still exists. So I hate this kind of formatting. How do I... My space orientation is bad. So if we copy this and put it here, yeah, that's what we wanted to copy. Okay, so we want to match architecture. What architecture? S390X, and we will say this is emulated roots built are done on x86 using QEMU. Okay, why not? Right. So what the hell do we do with this file though? We changed the file, but that's it? Do we restart the copper front end and that's it? I have no idea. So see, succeeded running, and this is still starting. So this is as expected. Maybe let's finish and maybe let's wait until this build finishes. And then this root finishes, and then we will try to restart the copper front end. So if we go to settings, and there is the list of roots, and these are the comments, right? So for example, for the RISC, we can see it's an emulated root, and for some other, what was the one? It was RISC and ARM HFP. Yep, you can see the comment also here. So maybe when we restart copper frontend, it will automatically reload that config file and it will print the comment here. That's possible. That would be good. So what's going on here? Still running. Oh, I remember. RISC-V is kind of RISC. Is this RISC-V? I think it is. Is slow. I have read a blog post recently. Can I find it? It was an interesting one. So favorites maybe. Let's search Fedora RISC. That's unfortunate. I wanted to show you the blog post. Okay. So never mind. I have seen some blog posts. It takes much longer on RISC-V than other architectures. So let's not wait. Let's try to restart the system ctl restart copper frontend no, not copper frontend, HTTPD service, right? The copper frontend is running through HTTPD. So we have that. Now if we refresh the page, everything should load again. Hopefully we'll see the comment. And we don't see the comment. So that's not helpful. Now let's see in our code base if we use this or what. Yeah, you know, it's weird. Copper. So git grab this one. So chroots template. Should we? Oh yes, back to the documentation. I think we maybe are supposed to run this command. So back here and run this. It will error out that we need to run it as a copper user. Yep. So we will copy the same command and run it as copper front-end user. Now we did that, so if we refresh the page, yep, we can see that now. So S390X is emulated chroot. Good. So I suppose this command, this copper front-end chroots template, is being run in our Ansible playbooks, and I suppose the chroots.conf comes from our Ansible playbook. So we are going to check that. Let's go to here and Fedora infra Ansible. Maybe let's git pull rebase as usual. Okay, so git grab, not grab, let's find grab chroots conf. Yep, see, it's here. And if we git grab this, install config 4, and it is being run, it seems. So let's go to Emacs, Fedora infra Ansible, and this is tasks main on front end tasks main. So chroots conf. Install config. We copy this file from Ansible into the system here, and it registers this. And when this changed, we run the command. Okay, that's cool. So the only thing that we need to do here is chroots conf. We need to change this file. And commit it to the Ansible repository, and then once we run the playbooks, it will automatically put the command here on production. So we are going to do that. So we need to copy this, put it here, arch S390X, and the rest is the same. So that's good, but this doesn't mean our chroot is emulated, right? We just added a comment. So that's not it. We need to dig deeper, but we don't have any more documentation for that. So my next thing would be, let's go to copper code base. Maybe let's put this on the side if we need it later. Let's go to copper code base and find models.py and search for emulated. Okay, not here. So I thought maybe in the database there will be like emulated boolean, which would say if the chroot is emulated or not, but that doesn't seem to be the case. If we go to database, and we see our, I don't know, build chroot, copper chroot table. So we have mock chroot ID, we have copper ID, we have stuff. I think mock chroot ID would be more interesting. So let's see mock chroot here. And here is where I expected to be the boolean, right? Because OS release, OS version, and architecture. If you take these three, you get the full name of the chroot, like Fedora 43, PPC something something, all right? Fedora 43 S390X. So if you take these three, you get those. So I thought, and here is if it's active, right? The comment is actually here, put here from the command, from the config that we created. So I expected the emulated boolean would be here. That's not the case. So the other possible place where this could be is the pools config in the Resalloc configuration. So when I talked about the resources and the pools here, and if I go to pools also, there is the list of all the pools that we have, right? This is all the pools we have. These aren't maintained directly by the Copper code base. We created a separate service that is called Resalloc, and that maintains the VMs in the various pools. And the only thing that Copper codebase or Copper backend does is it sends a request to Resalloc, basically, and says, hey, give me a machine that can build for the x86-64 architecture. And Resalloc is in charge of figuring out, like, hey, what machine, where, and so on. And it has some logic to do the cheapest ones first, and you know, all the stuff. So we are not going to look into the Copper configuration. We are going to see the Resalloc configuration for every pool that we have here. So if we go to backend instance, of course, staging again, and we go to etc Resalloc server, and here is pools YAML. So this is a long file which contains configuration for all of those pools, right? So I suppose somehow it will be here. From what we know in this config, for example, the RISC-V architecture should be emulated as well. So if we search for this, okay, so it says, so basically we have some tags that say the architecture is emulated. Not that it's emulated, but I don't know how to interpret this tag actually. So yeah. So basically, check this out. We are in the x86-64 pool in AWS, and it says I can build AWS stuff, I can build x86-64, I can build it natively, I can build these other stuff, and then it says I can build RISC-V. So, and you can see it doesn't have RISC underscore native, so that's correct. So basically, we can maybe put this here. And what did I do? I wanted this. And basically change this to S390X, and same with the emulated one. And then maybe it will start working. To be honest, I have never done this, so this is like a full experiment for me. Now, yep, this is exactly in the state that we expected in the beginning. Okay, so let's save this. Now, do we need to restart something if we change pool's YAML? I don't think so, actually. I think Resalloc automatically reads that file on changes. So I don't think we need to restart anything. But we actually might need to. So Resalloc. We don't need to if we change the limits of how many builders should spawn in that pool. But if we go here and do Resalloc main resource list, right? So this is not very clear. It's basically the same thing that we have seen on the website, but in the command line. But basically, if we search for so first of all, I don't see any AWS. Okay. So back to the config. There is a negative priority. So basically, we basically don't want to. Oh, this is a powerful pool. So we don't want to spawn these if we don't need to. So that was a bad place where to test this. So these powerful builders are, I don't know, 10 times stronger than the normal builders. So they are used for kernel and whatever, Chromium and so on. And we don't want to waste these resources, so they are not going to be spawned just casually. So let's search another of these. So yeah, we can put this as, oops, I don't want to do that, as 390X. We will put it also here. This is a pool of builders on our hypervisors, so we don't of normal builders, so we don't mind wasting these basically, because the hypervisors are only ours and we use them only for builders. So yeah, we can. They are probably being spawned immediately. So let me just take this, and if we go back to the Resalloc user and we do the resource list again, but we will grab the name of the pool, so we can see we have this one instance running in that pool, and we can see the tags here, which is what we changed in the config, right? But my guess is that since this machine was started before we updated the config, it was started with the tags it had before, and they won't change for this machine actually. So we can confirm that. We can see the RISC-64. We can see the ARM somewhere here, but we don't see the S390X, right? We can grab S390X. It will be empty. Yeah, exactly. So what we are going to do is kill this machine. So we are going to Resalloc not close ticket, Resalloc main, I know the command, resource delete on this ID, right? So now it will be in the deleting state. Delete request, yeah. And soon it should disappear and a new machine should appear with a different ID. Still deleting, okay. A new machine with a new ID should appear. And I think originally it will has its tags empty. But once it starts fully, it will have those tags populated, and I think the S390X should be there now. Okay, delete request for a long time. That's weird, isn't it? So we can probably take a look what's going on in tailf var log resalloc server. I think hooks, and there should be something matching the resource. And interestingly enough, there is no delete, see, terminate or release. I don't know which one I would expect, but there is not either of those. So one thing I'm going to do is I'm going to restart Resalloc. I will do that, and then I will tell you why, and that will be that. So system still restart Resalloc service, and let's go back to the Resalloc user, and let's do this again. Still delete request. So why I wanted to do that, we just had an outage in production. If I go to Copper tickets, issues, so this was reported. We had an outage and we weren't building new stuff, and it turned out there is I found some traceback in the logs, this one, related to Resalloc, and I think maybe this was the cause problem. This is a Resalloc ticket, so I think maybe this was the cause problem, the root problem, and I'm going to debug in the in the work week. Basically, it's Sunday today, so I didn't want to spend my day on this. But yeah, so this could have been the root cause, and basically this causes this causes problems when trying to delete new builders. So that's why I think maybe it happened on the staging as well. So possibly no. Okay, no. So it didn't happen on staging. It just refuses to delete stuff. So okay. Another idea. Let's go to pools and search again. Do we have? Okay, there is another VM host, so let's put it also here. And this is what? Okay, let's do it. S390X. So let's take this RISC 64, RISC v64. Everywhere where we have this, let's put also the S390X. Right, so we put here, we will put it also here. So on all of our hypervisors it is possible. One of our hypervisors is dead, I don't know. This is spot instances in AWS, so yeah, let's do that. This is a powerful one in AWS, so it will not matter here, but let's do it. Yeah, okay. So we put them everywhere we could, basically. Now we need to do the same thing. We need to restart the or kill the builders and start the new ones because we want those new tags. And as we did delete before, delete, right? We can do all instead. We will remove all of the builders from all of the pools and they will all restart. So we can do list here again. Everything should be in delete request state, right? And if we do grep starting, nothing should be there basically, but hopefully soon they will be. Maybe just that one hypervisor, that one pool that we tested originally is stuck or something. Hopefully the rest of them will work. Yeah, well, interesting. So can we see some Resalloc logs, like the main server logs? Resalloc server main log. Ooh. Okay, that's the reason. That's the reason. So did we fuck up something? Well, we needed to, because so asset dark, not in self dark, set normal. I have no idea what this is. Okay, let's go manager in Resalloc codebase. Resalloc manager, line 614. So this is validate on demand. And we are validating if this tag is in this set, where this is being called from. On demand set tag set on demand. Okay, so what I'm thinking, maybe there weren't any S390X on demand powerful builders before, and now we added them and it causes problems. So we are going to edit the pools again, and we are going to remove the S390X from the powerful builders, right? So This is the Amazon configuration. No, Amazon IBM Cloud configuration. So this is broken now. Okay, back from I don't know. Are we at the beginning or it doesn't matter. So this one is normal. This one is powerful. So let's get rid of it here, right? Same here, this is powerful as well. This is normal. This is normal. 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 Okay, and we are back on the IBM Cloud configuration. So we removed the S390X from the powerful pools. Now if we go to Resalloc and we so what is happening now? We are still seeing a problem here. Set normal. Oh God. So we are still invalidate. 614. 614. Well, I don't know. I don't know. Where do we put it then? What do we do with it? So let me take a look at the, by the way, can we edit the config as a Resalloc user? Pools, YAML. Can I save it? I can. Okay, so we don't have to switch to the root user to edit the config. Now, S390X. Like, what is the problem with putting it here? So previously, okay, what if we temporarily comment out the S390X emulated? Could it be caused by that? Emulated, right? So let's comment this one out, this one. Right, now they are all commented. Okay, so let's see now. Still the same problem. Why? Can we go to, does Resalloc have some document? I doubt that. Let's see, emulate, no. So I don't understand this. So we go for all tags in... Oh, I see. We go through all tags in on-demand tags, and we are making sure they are not in normal tags, and that is causing us problems. You know what? Let's restart Resalloc. And let's see now. Okay, still a problem. So, which would basically mean that we have our tag in on-demand powerful. So let's search for S390X once again. Arch, this will be better. Let's start from the top. Okay, so that's fine. That's fine. That's fine too. Okay, and now here is the... So here may be the problem, because S390X is here, and this also has on-demand powerful. So maybe this causes the problem actually. Okay, we will get back to that. Okay, so let's try this theory. So how do I... Can I do this and insert something there? Like somehow I know I can somehow do it. Anyway, let's do it like this. Let's do it like this. Okay, so now if we tail the main log, still this starts to piss me off though. Was this the... I commented a wrong one. I commented the wrong one actually. Where is it? Where is it? Here, this one. This one. So, like this, we will copy this and put it here. So I never know how to do that, how to do this correctly, because in my config I have a plugin for that, and I just GC and it comments the block. So I never know how to insert this for multiple lines at once. Doesn't matter. Tail. Okay, I'm annoyed. I'm officially annoyed. Let's see on-demand powerful instead. So okay, this one doesn't have the S390X. This one doesn't have the S390X as well. So I mean, I don't understand the problem then. Let's try to restart it again. I didn't, of course it doesn't help. So does this mean that all of these were okay? And then it either failed on this one or the next one, possibly. So if we open the config and find this config, so either it fails on this one or the next one. Oh. Okay, so or possibly it just goes through all of them and then does the validation. So that lead is bad as well. What the hell do we do with that? So since we are on a staging instance, why don't we just edit this file? It's 6.14. And why the hell don't we just print tag here, and we can also print this whole set, and we can also print this set, right? Why the hell not? So we are going to restart Resalloc. We are going to tail frlog Resalloc main, and we will see if there's anything interesting. Oh, we cannot print it, of course. We need to log it. Uplog, okay. So let's go here. So this will be uplog. Let's do error so that we can see that correctly. Same here, right? Restart and tail. Okay, we have it here. So this is our first set. This is our second set. I forgot which is which. The first set is the on-demand set. Okay, so we have the on-demand. We are going through all of these. We are going through all of these and making sure they are not here, right? And then this is fine, but this is here, if I understand it correctly. So, yep, this one is here. The native one isn't there. Okay, okay, that's sure. But then, why this one is here? Why this one is here? I mean, not this one, this one. If we open the pulse YAML again, so what we are going to do is we are going to delete this and this and also this. All of these. We are going to delete all of these. Right? So now we have the S390X only in the places where we added it, not in the IBM cloud. Now we are going to, we don't have to restart and we can see the logs. Okay, so it does stuff now. And I suppose it will start building here soon. This was just painful. Still nothing, okay, but that's probably fine. It may take some time, I don't know. Let's see. Resalloc list grep starting, that's not useful. Oh, they maybe just start. Okay, so we fixed the bug in. Yeah. We had a problem. Delete them even, right? So we deleted them now, and we are starting them now. So this should take 3 minutes before they are up and running, and then we can see if it builds. So soon we hopefully should see some app builders, and we can, for example, I don't know, what do we believe will start the soonest? Let's say this one, and let's see tailf varlog resalloc server hooks this one. Okay, so we can see the Ansible playbook that is being run on the VM now. And yep, it finished now. We have the IP address here. So if we take a look at the app builders now, it should be there. Yep, we already have some. And Let's take a look at this one, right? The VM host. So this is the builder on our hypervisor, and it has the emulated RISC and ARM FP. Should it have the S390X as well? I think it should, but I don't see it. Grab S390X. Yeah, it's somewhere. Yeah, so I just don't see it, but it's there. Jesus, I'm just blind. Vim S390X, it's here. Okay, it's there, that's cool. So if I refresh the page, yep, it's running. Okay. Okay, this is great. So basically this is what we need to do on production to make sure the builders are running again. Now we removed all of the configuration for the IBM Cloud. The problem is I don't want to do that in the production config, because, as I said in the beginning, one of my co-workers is going to try and get us renewed access to the IBM Cloud for the end of the year. It should unofficially work, but maybe I'm completely maybe I completely misunderstood, but this is what I understood. And so that I don't want to remove all the configuration, so that we would then just revert and put it back. So I would probably like to just like disable it or something. I don't know. I would like to do an equivalent of, like, for example, if you go to my, I don't know, .files and my Emacs config, I have some enabled packages here, and if I search for disabled, right, so I have this block here, but I just have disabled true, and it doesn't like evaluate. So or it evaluates, but it doesn't do anything. So an equivalent of this in the pools YAML, right? So disabled true, for example, or something like that. I don't know if that's implemented. I kind of doubt that. So I kind of think we are going to cut the video soon, because we figured out like how to do that. The minor thing of figuring out how to have both of those configurations enabled as at the same time, I will probably do later, but I will show you something. Let's take a look at the right side. This is the Ansible configuration, right? So if we search here and search for pools YAML, right, there is pools YAML, and this is the config. This is a template of the config that is then being put on our server here, right? Here it is much more disgusting, because it is a template and it is generated from some configuration within the Ansible playbook or repository. So for example, we somehow have these variables for every pool and so on. So this is much more complicated here than the fully evaluated form. I will need to put the stuff here somehow, right? We should be able to find that section. Like if we search for the risk V, right? So wherever this is, we will probably just put the S390, right, here, and on all those places, and that will be it. So that's something I'm going to do later. And then we also have pools YAML expand sh, and this is a helper script to expand the pools YAML locally on our system. So it should take the disgusting template, evaluate it, and we should see like the fully evaluated pools YAML, but on our machine before we commit the changes. So then we can evaluate it and save the result, and then we can play with our changes and see the diffs, right? And we can maybe try that together, but I will do the final fix later, right? So yep, this succeeded. Cool. So this is what we need to do in production, right? Basically. So let's try this. Where is the script? It's here, right? So if we borrow this path and we go on my machine, and I basically do this. Oops, here, and there is the script somewhere. This. Okay, I have no idea what that did. And I git status. Okay, these are not in the repo then. These are being put here. TMP pools debugging. Okay. Can we jump quickly here? So ls, we have devel pools, we have production pools, so we can edit the, I don't know, let's do the devel pools. And you can see it is the evaluated file, no variables in this, right? And this even created a Git repository for us. Update. So I can git show, yeah, I can see the config. Okay, so we have the config now, basically. Okay, if I jump back to Ansible, and then I do changes, right? So I do changes in pool YAML. And for example, what I wanted to do, I don't know, in this AWS, I wanted to put the Arch S390X and emulate it, right? This is something I wanted to do. Okay. So this is something I wanted to do. Now I can run the script again, and it should do the changes in the repo that in the temporary repo. So we can go back there and we can see git status, git log, and we have 2 commits now. So I can show the last commit, and you can see it only added the line, but into multiple places, right? So this is how I'm going to debug the server. This is how I'm going to debug the config, and then before actually deploying it in production. Now I'm just thinking, what if maybe we configured or we changed the pools config manually on the staging machine, right? Maybe we just fucked something up. That's entirely possible. So what if we just take this file and we just put it into the right place and see if Resalloc finds it okay or not. So what if we SCP this file into our copper FE dev, and where, well, that's actually going to be this path, right? So we are going to copy it here. I don't know if it will mess up some permissions of that file, but no. Backend, not front end. Okay, it uploaded devel pools, but hopefully it put them here. So if we go back to the server, we edit this, we should have, see, if you remember, we removed this part previously and it is now there. So yeah, we successfully uploaded that configuration. If we tail our main log, but it causes problems again. Yep, it causes problems again. So anyway, this is how I'm going to debug this, right? I'm going to do changes here. I'm going to produce in the template, I'm going to produce the actual file. I'm going to SCP it on the server. And once it is working, that I could of course remove the blocks for the IBM cloud. I don't want to do that. I want to do something else. And once it starts working, I will have my Ansible playbook change actually, and that one I'm going to commit to the repo. I'm going to push it and I'm going to run the playbook with this change against the production machine, and that will be that, right? So the only thing that remains is to debug how to have the this here while still having the S390X configuration in the IBM cloud. But that's something I'm going to do later. It's Sunday and I want to go to the gym, so yeah, I'm ending it now. I will continue later to have it ready on tomorrow morning. Basically, I want to deploy this to production tomorrow morning. So yeah, thank you all for watching and see you next time. Bye bye. Even though this was fucking painful, by the way, but yeah, we needed to do that. So thank you all for watching. See you next time. Bye bye.